Okay, thank you, students. Today I am very happy to meet all of you in the first semester. That means first time I am seeing you, second MSc mathematics students of B section. The subject given to me is fluid dynamics. That's what I have to handle with you. Okay, right. Now, let us, in this nearly 15 minutes, we are going to talk about this fluid dynamics syllabus. So, syllabus analysis, that's what I am going to do now. Syllabus analysis. Fluid dynamics means the dynamics of fluid. I mean, when the flow moves, what are the forces acting on that? What are the equations connected with that? That is study is called fluid dynamics. Fluid dynamics. That's what we have to understand. Okay. The first unit in the fluid dynamics is unit number 1, kinematics of fluids. Kinematics of fluids in motion. That's what the first topic. So 18 hours is given to finish all these topics given here. Okay, right. Here we are going to study about what is a real fluid, what is an ideal fluid. Okay, so real fluid means the movement of the particle cannot be treated as a point, whereas ideal fluid means the movement of the point we can take as a point. If you take as a point, then we can apply mathematics and thus we can develop the mathematical ideas. So the first unit we study about real fluids and ideal fluids, velocity of a fluid at a point, streamlines and path lines. There are two types of lines, streamlines and path lines. That's what we are going to study. Then steady and unsteady flows. The velocity potential. The velocity potential it has its own differential equations. And then the vorticity, vector, local and particle rates, the change, the equation of continuity. This is very, very important. In the university examination, they may ask you, derive the equation of continuity. So a lot of worked out examples we are taking and discussing on this particular topic. Okay. Then finally, acceleration of a fluid. That's what we are going to discuss about that. Okay. Right. Next unit is about unit 2. Unit 2. Okay. The equation of a motion of a fluid. Again, this is the title. Under this 18 hours, we have to discuss about these particular topics. Okay. The first one is the pressure at a point on a fluid at rest. Fluid at a rest. Take for example, this is a movement of the fluid. Okay. Now what is the pressure at this particular point? What is the pressure at this particular point? Okay. We are interested in that. So next about the boundary point, the fluid condition at a boundary of two invisible, immiscible fluids, Euler's equation of motion, that's very important, and Bernoulli's equation, worked out examples, lot of examples we are to take to discuss about this, okay, right. The next, then we are going to study about discussion of this case of steady motion under conservative body forces. Now coming to the third unit is about some three-dimensional flows. Again, three dimensional flow we have to take into account. We know that three dimension means x, y, z. Okay, the point on the movement of the fluid based on the three dimension x, comma y, comma z. So from that we can define what is sources, what is sink, what is doublet, and also images on a rigid infinite plane. This is what we are going to study. Axiomatic flows, Stokes stream function. This is also very important for the examination point of view. Okay, so these are some of the things that we have to understand. Okay, so Stokes stream function, that's what also very important. Now next one is unit number 4. So what the unit number 4 is some two-dimensional flows. Two-dimensional flows. Again, it needs 18 hours to discuss about the topic here. Okay, meaning of two-dimensional flows, use of cylindrical polar coordinates, the stream function, the complex potential for two-dimensional, irrotational, incompressible flow, complex velocity potential for standard two-dimensional flows, and some worked examples. So these are what we are going to see under unit number 4. Okay. Now, finally, the unit number 5. What the unit number 5 is about this. So, unit number 5 is about viscous flow. Again, 18 hours are needed to complete this topic discussion. Viscous flow. What is viscous flow? Stress components in a real fluid. Relations between Cartesian components of stress, translational motion of fluid elements, the rate of strain, quartic and principal stresses, some further properties of the rate of strain, quadrate, stress analysis in fluid motion, relations between stress, and all these things that we are going to study here. Laminar flow and the Navier-Stokes equations of a motion. So totally 90 hours is needed to finish the whole portions. Okay. So my dear friends, it's a good time and good day for you to study this all syllabus. Okay. So I welcome, and the next session we will start our first topic. So till then, goodbye. And now, what is this about this fluid dynamics? Okay, so fluid dynamics, on the other hand, I can draw the picture here so that you can understand. Suppose this is a fluid point, fluid motion here, and here's some point. Then you have a velocity q in the u direction, v direction, and w direction, and this is called a velocity component of the moving points. So in the next class we will study some other things. Okay, we will start our syllabus in the next session. Okay, till then, goodbye.